So saying extraordinary claims require extraordinary evidence and then not providing any funding towards the search is a circular argument. And nobody said that the lightest supersymmetric particle is an extraordinary claim, therefore it shouldn't be funded. People said, oh, that's interesting, let's check it. And they put billions of dollars. Now, why can't we apply the same approach to objects that came into the solar system that look weird and just examine them, because maybe one of them would be a spacecraft?
Are we alone in the universe? Are UAPs real? We are going to discuss this today on a new StarViews podcast with two Mondadori best-selling authors, Mauro Biglino and Avi Loeb. Professor Avi Loeb is a professor of science at Harvard University. The Time magazine selected Avi Loeb as one of the 25 most influential people in space, in astrophysics. Avi Loeb is the founder and the chair of the Galileo project, of which we are going to talk about today. He has also published recently a book in Italian, actually Italian translation of the book that came out a couple of years ago about Oumuamua. And the title of the book is We Are Not Alone, Non Siamo Soli. Welcome back, Professor Loeb.
Thanks for having me. It's a pleasure.
Mauro Biglino is a Bible scholar and translator. He has published 17 books of the Old Testament for the Interlinear Bible for the Catholic Italian publishing house San Paolo Edizioni. He's also a best-selling author for Mondadori. Welcome back as well, Mauro Biglino.
Grazie molte.
We also have a special guest, astrophysicist Giovanni Zattera from the Technical University of Munich, who will help me with anything that might get lost in translation, so that the conversation will be easier. Grazie, Giovanni.
Thank you for having me. It's my pleasure to be here.
Professor Loeb, I want to start with you and your book, because the Italian translation of your book on Oumuamua just came out just a few months ago. What I noticed, though, is that the title was slightly different, because the English version is Extraterrestrials. The Italian version of it is We Are Not Alone, Non Siamo Soli, We Are Not Alone. Are we not, Professor? And if we are not alone, who else is out there?
Well, that was an initiative by the Italian publishing house. It doesn't change any of the views that I had on the subject. I should say that one development since the book was published in English a year and a half ago is that it turns out that Oumuamua, the object that I focus on in the book, which was the first one reported by astronomers to come from outside the solar system, is not the first interstellar object. That in fact, almost 4 years earlier, there was another object that was detected as a meteor, roughly the size of a watermelon. And it was detected by US government sensors. And the way that we came across it is I was interviewed on the radio and about another meteor. A meteor is just an object that the Earth collides with as it moves around the sun. And so usually these are rocks that belong to the solar system, asteroids or objects from the outer solar system. And in this case, I looked online and I found a catalog that the US government compiles. They have a missile warning system, so they monitor the atmosphere, but every now and then they detect an object coming into the atmosphere from outside and they realize that's a meteor. That's not a Russian or a Chinese rocket. They published a catalog of 274 such objects. And I asked my student, that was in February 2019, a few years ago, I asked my student Amir Siraj to look through the catalog at the fastest moving objects. Perhaps one of them came from outside the solar system. And indeed, we found one that was beyond any doubt moving much too fast. It was, when it was detected in the lower Earth atmosphere, it was moving at 40 kilometers per second, but going back in time, it was actually moving at more than 60 kilometers per second relative to the sun outside the solar system. So it was clearly unbound gravitationally to the sun, and we declared that to be the first interstellar meteor, an object that is big, that came from outside the solar system. And when we submitted the paper for publication in March 2019, the reviewers of the paper said they don't believe the US government. Maybe the uncertainties are very large. To me, it was pretty clear that if you're looking for ballistic missiles, you need to know whether a ballistic missile will hit Boston or New York City. So the government uncertainties must be quite small. But at any event, the paper was declined. And as a result, I asked for assistance from within government. And in March this year, there was a letter from the Department of Defense, the US Space Command, to NASA, confirming that this object indeed had very low uncertainties in the velocity measurements, so that at the 99.999% confidence, they confirmed that it came from outside the solar system, the way that our paper argued. And that removed any doubt. And now our paper is reviewed again and hopefully will be published soon. But more importantly, we are planning an expedition to the site where the meteor landed. And it exploded about 18.7 kilometers above the ocean, 100 miles off the coast of Papua New Guinea. And it disintegrated, exploded, released a few percent of the energy of the Hiroshima atomic bomb. And of course, the question is, what was it? And the government, together with the letter, released the light curve of this meteor explosion, the fireball. And from analyzing it, we inferred that it was very tough, tougher than iron, because it only exploded in the lower Earth atmosphere and it was moving very fast. So it must have sustained very strong pressure from the air that it was going through. And we found that it was tougher than all other 273 objects in the catalog. So clearly an outlier, and tougher than iron, tougher by a factor of 2 than the next object in the ranking. And that means that it's unusual in its strength, material strength. Moreover, it was moving faster than 95% of all the stars in the vicinity of the sun. So clearly an outlier. Again, this was the first interstellar object. Oumuamua was the second. That's my book. And the first 2 interstellar objects appear to be strange. And you think about it, you know, you look at your backyard and you find objects from the street, and they don't look like the objects you had in your backyard. So that means you're missing something. And in this particular case, the fundamental question is whether it was artificial, this meteor, or natural. If it was natural, it could have been an iron meteorite, but iron meteorites make only 5% or less of all space rocks. And this was even tougher than iron. So the question is, what was it? And we're planning the expedition to examine its composition and figure out if it was artificial. And my wish is that we will find a chunk of material that has some buttons on it so that I can press a button. But we don't know what we will find. It's a fishing expedition. And I'm very excited about it because if we, you know, as part of the Galileo project that we will discuss, if we were to design a space mission to rendezvous with the next Oumuamua, that will cost more than $1 billion. The expedition that I'm talking about to the ocean floor, to scoop the ocean floor, will cost 1,000 times less. So we have an opportunity for the first time in human history to put our hands on material from a big object that definitely came from outside the solar system. So that's the latest development. And I'm excited because I think, you know, science should be driven by evidence, not by people going to social media and making statements, because that's pretty much noise. We should ignore that. I don't have any footprint on social media for that reason.
So basically, if I understand correctly, you are thinking that this first object that came from outside the solar system fell in the ocean, and now you are launching this mission to go retrieve some of the material. This is quite interesting.
This is very exciting, and yeah, it's very exciting. And over the past few days, there were lots of news reports about it. I was just interviewed yesterday on NPR. You can find a segment of 3 minutes there, and NBC aired a couple of nights ago a segment on that. So altogether, I think the public is also quite excited, and we will go there. It's sort of like going to retrieve scientific evidence, like Indiana Jones in the movie, you know, trying to do something. But it will not be easy. We have already the machinery designed, and I received already possibly, you know, most of the funding. I still have to confirm that, but it will cost about $1.5 million. And I received 1/3 of the funding already, but then the 2/3, I'm working on it, and hopefully I will get it very soon.
Okay, so your hypothesis, if I summarize very briefly, that these two interstellar objects make you think that we are not alone in the universe. This is an hypothesis, of course, because they behave in a way that they might be artificial, correct?
Yes. Suppose you were a kid, okay, you grew up at a home, and you are used to all the objects that you find in your backyard. Okay, just think as a kid. Suddenly you realize, oh, here are the first two objects that I noticed from the street. And they look very different. And they don't look like rocks, okay? They don't look like the rocks that you found in your backyard. So it raises the possibility that you have a neighbor. And right. I think that's common sense. Now, why would the scientific community be hostile to that possibility is unclear to me. There was just a paper on the archive last week saying that 80% of all astronomers in Scotland, you know, appear to have, you know, they went to pursue a career in astronomy because they were inspired by science fiction. Okay, so given that factoid, you wonder, why is there hostility? I mean, people enjoy reading science fiction, but have a difficult time putting the storyline into action. So the thing is, I don't like science fiction personally. I enjoy doing science and reading fiction. But if you have evidence that looks unusual, that is anomalous, then you should attend to it. You know, for example, we've been searching for the nature of dark matter for decades. Originally, it was Fritz Zwicky that suggested it in 1933. In the first 40 years, the subject was ridiculed. The mainstream did not want to accept that there is another type of matter in addition to the one we find in the solar system. But guess what? The universe is mostly made of stuff that you don't find in the solar system. And that's a message that by now penetrated the mainstream of cosmology and astronomy. Everyone accepts it. You ask any young person, of course, there is dark matter. We don't know what it is, but we know that most of the matter, 80% of the matter in the universe, is not the matter that we find in our backyard of the solar system. Okay, so that we know. But why wouldn't we consider the possibility, if the first two objects that came from outside the solar system do not resemble the rocks that we have found in the solar system, why don't we even entertain the possibility that they're artificial in origin if they look so unusual and they're so weird? And, you know, I discuss Oumuamua in my book. The meteor is basically, the composition must be tougher than iron, and it moves faster than 95% of all the stars near the sun. So that raises the possibility that it's a spacecraft in principle. And we should be open-minded. And of course, if we end up scooping the ocean floor and finding fragments from an iron meteorite that resembles the rocks we had seen in the solar system, I would, of course, admit it. There is no doubt. But it should at least make us curious to ask, you know, why the first two objects look so weird.
And we are certainly curious. I'm actually curious to know what Mauro Biglino think about this. What does it sound to you, Mauro?
But you have explained all this very well in your book that I read. But I have first of all one question about the famous Blaise Pascal wager that you about that you are talking in your book, and you wrote this also. Among all astronomical data, the discovery, sorry for my English, of course, the discovery of alien life could have the greatest impact on our broad outlook. And what if we have already made that discovery? Because that has also a great implication on the open-mindedness of the scientists. And of that you are talking in this book, of course.
Yeah, I mean, what you are raising is exactly the reason we called the project that I initiated the Galileo project, because the Galileo Galilei established the scientific method, and he was put in house arrest. Today, he would have been cancelled on social media because his view was not accepted at the time by philosophers. But my point is, reality is whatever it is. It doesn't matter if most of the people put blinders and not accept something, and we may discover the same thing again and again. We just accumulate more evidence for it. So I completely agree with you. It doesn't need to be original as long as it's true, okay? And the resistance, you may ask, where is the resistance coming from? Well, one tendency of people is to think that they are at the center of the world. You know, that was the idea, that the Earth is at the center of the universe. And we now know that's not the case. And in fact, not only that, we came to exist only at the end of the cosmic history. The universe existed for 13.8 billion years. So if you arrive at a play, at the end of the play, as an actor, and if you are not at the center of the stage, clearly the play is not about you. Okay, now people have a hard time accepting that. But my point is, we should be humble. Now, the reason, I mean, it's for the same reason that religion advocates being humble, because there is more to the story than us. So I'm saying, you know, there is something common between theology and spirituality and exploring the unknown in science, because when you explore the unknown in science, you should have a starting point that doesn't put you at the center. In other words, you should be humble. You should imagine that there is much more to the story than you, okay? And that's something difficult. It's difficult also for experts, because imagine experts that are used to finding rocks in the sky. So anything that is in the sky, they would say it's a rock. That's what they said about Oumuamua. And even if, you know, it doesn't look like the rocks we are familiar with, they would say it's a rock of a type that we've never seen before. A hydrogen iceberg, a nitrogen iceberg, a dust bunny. These are the possibilities that the mainstream astronomers suggested for Oumuamua. We have never seen any of those before. And moreover, they have difficulties. They have problems, each of these proposals. And, you know, that's a sign of trying to maintain your expertise, your image, your stature as an expert. And once again, it's the ego. People want to keep their reputation, so they say it's natural, but of a type that we've never seen before. And to me, it reminds of a cave dweller that finds a cell phone. A cave dweller would argue the cell phone is a rock of a type that I've never seen before, because the cave dweller is used to playing with rocks. So it's not difficult to understand why people respond in this way, but it's all to do with the human ego. And I'm saying, put that aside. That's irrelevant. Let's use evidence to guide us, which is fundamentally what Galileo said.
Okay,
Professor Loeb, I wanted to ask you, other than this new expedition that you're organizing to retrieve material from the bottom of the ocean, are there other progresses for the Galileo project? Have you started? Did it become operational already?
So in fact, last week we had the first conference of the Galileo project where we summarized the first year accomplishments, and we are planning ahead for the next year. And the project is already operating for 1 year. It was established in July 2021 based on funding that I received from multi-billionaires that visited the porch of my home after reading Extraterrestrial, my book. They were inspired by the vision, and they donated a few $1 million to my research fund at Harvard, and that allowed me to establish the Galileo project. Now, the project has 3 tracks. One of them is this expedition that I mentioned. Another one is to rendezvous, to meet the next Oumuamua. It's sort of like dating another object that looks unusual. And we have a dating app, which is the Vera Rubin Observatory in Chile that will start operations in a year. And the reason I call it a dating app is because it will find objects like Oumuamua routinely every few months. And then we have to decide whether to rendezvous with that object or not, so that we can take a close-up photograph of it. And you know, this kind of a date costs $1 billion. So most of the time we will swipe to the left, but we might decide to go after one. And in the Galileo project, we are planning the details of that kind of a space mission to come close to such an object, get a close-up photograph, because they say a picture is worth 1,000 words. In my case, 66,000 words, because this is the number of words in my book. And then the third track of the Galileo project is to build a suite of instruments that monitor the sky, because the US government, a year ago, the Director of National Intelligence reported to the US Congress that there are objects in the sky whose nature is unclear. These are called unidentified aerial phenomena. And since then, the Congress established a new office in the US government that accumulates that data. NASA established a new study that just started to look into whether this should be funded, this research. And the Galileo project is already doing that. So we built a suite of instruments that monitor the sky in the infrared, in visible light, in the radio and audio. And we hope to make it operate and work within the coming months. And then starting in 2023, starting to get data by monitoring the sky in various locations of interest and getting high resolution imaging or high quality data on the objects the government is talking about to see what they are. And it may well be a mixed bag. Most of them may be human-made, drones, airplanes, weather balloons, or natural, like bugs, birds, or meteors. But it's sufficient to have one object that behaves in ways that human technologies cannot reproduce and that nature cannot reproduce for this to be worthwhile. And that's what we are trying to find. The government, of course, is mostly interested in national security, and they want to know if it belongs to another nation. For us, these are not the objects of interest. So hopefully, you know, within a year, we'll have data with interesting results. So that's the third track of the Galileo project. So we have these 3.
One object is enough. One object is enough. Mauro, I want to ask you, should Avi Loeb be successful in his challenge? What do you think is going to happen next? How do you think? Because I remember last time we spoke, Professor, you said that the day that we find out for sure that we have proof, evidence of extraterrestrial life, this is going to be day one of a new era for humankind. So Mauro, we are in the field of conjecture here, but how do you imagine this day? Come pensi che reagirebbe l'umanità?
See, first of all, this question is a little complex, so I'd prefer to answer in Italian, if it is possible, and John will translate for me. Allora, io spero innanzitutto che abbia ragione, perché leggendo il suo libro vedo che è necessaria l'apertura mentale da parte della gente, da parte degli scienziati.
So first of all, he hopes that you, Professor Loeb, are right, that, I mean, concerning extraterrestrial life. And he is basically saying that this sort of open-mindedness is crucial. So it's important to open this conversation right now on the side of the public and on the side of the scientific society.
Perché io penso che le persone che non sono condizionate da necessità di carriere o di altri motivi devono avere la mente aperta quantomeno per accettare queste possibilità, anche se al momento noi non abbiamo ancora delle evidenze certe.
Because those that do not have a conflict of interest, those that can afford being open-minded, they have the duty to be such, so that we can push forward this sort of research.
E quindi questa ricerca che è portata avanti è fondamentale, come dice il suo libro, ora disponibile anche in italiano, proprio per questa scommessa sul futuro dell'umanità. È una cosa nella quale io credo profondamente.
He's saying that he believes strongly in this bet of humanity that something extraterrestrial or non-earthly exists. So although there might not be already some evidence of this existing, he truly believes in this bet that should be pushed forward by the scientific community.
I ask you a question, Professor.
Yeah, go ahead.
I'm puzzled by the fact that the public opinion, at least especially in Italy, is absolutely oblivious of this subject of the search for extraterrestrial life, despite the fact that there are public figures, very important public figures, from Barack Obama, Bill Nelson, many others, the Pentagon, the Congress, that have spoken openly about the fact that there are UAPs are real, they are there in the sky, we don't know what they are. They said that openly, black and white. But yet, it seems that nobody is interested in something that should be.
Well, that's because the evidence is indirect. Most of the data is classified, and those people, politicians that we trust, expressed their views based on classified data that only they saw. Now, you may ask yourself, why is it that the government will be the first to notice something unusual in the sky? And the answer is because it's their day job. The day job of intelligence agencies is to monitor the sky. You know, astronomers look at the sky, but in a very narrow field of view and at very distant objects. If a bird flies above a telescope, the astronomers ignore it. So the only agencies that monitor the sky routinely and look for unusual objects are related to the military and the intelligence agencies. So they would be the first to notice if there is something unusual, and they would not talk about it if they had a suspicion that it's the Russians or the Chinese or some other nation, because that's their duty to identify adversaries. The only reason for them to discuss it publicly is if they cannot figure out what it is. Now, they are not scientists. When it happens, when the government talks about it and it's not a matter of national security, then it should be a matter of science. That's the point where scientists should come to the stage and help the government, help the public figure out what. Now, the public may not be convinced at this point. It's not a popular subject. There is a stigma about it, but that's irrelevant. There was a stigma on believing that the earth moves around the sun, right? And who cares now about it? The philosophers back then that put Galileo in house arrest, if you were to ask them to design a mission that will reach Mars, they would never get there because they thought that Mars moves around the earth. So they had the wrong idea. So a lot of people can have the wrong ideas. We know that from politics, we know that from other sectors, but it doesn't really matter if people have the wrong ideas. The question is, what is the reality that we live in? And that should be based on evidence. And you know that because we should be sufficiently humble to be students of nature. Nature is educating us by us collecting the evidence, the data. And I should say there are two possibilities. you know, if there is another civilization, it could be either very primitive relative to us or much more advanced than us. The reason is that our technological development is only a century old. Modern science is only about a century old, since quantum mechanics, relativity were invented. And that's a very short time span relative to the age of the Earth. It's 1 part in 100 million. So finding another civilization that goes through exactly the current scientific development that we go through is very unlikely. You're most likely to find them the way we were 1 million years before the latest century, which is very primitive. And for that, we will need to visit the jungles on the exoplanet that they reside on. And that's very demanding for us to have a space mission that would reach another planet and then land on that planet, start searching the jungles for a primitive civilization. That would be very time-consuming, effort-consuming. The other alternative is that they're much more advanced than we are, okay? In that case, you don't need to do much. You don't need to go anywhere. They might actually visit us right now. And so all we need to do is look through the windows and check if we have neighbors, okay? And, you know, there is this statement by Fermi, Enrico Fermi, the famous physicist, who went to lunch in Los Alamos and said, "Where is everybody?" Well, at the time, he didn't use any telescope to look around, to check. And the only interstellar objects that we know about were recognized over the past 5 years. So my point is we were never engaged in searching for equipment. We only looked for radio signals. And radio signals are just like trying to have a phone conversation. You need the counterpart to be active when you are listening. And, you know, if you wanted to listen to cultures that existed on Earth in the past, you would never be able to phone them. You cannot speak on the phone with Wolfgang Amadeus Mozart. He's dead, okay? So as much as you hold the phone and try to dial numbers, you will never hear Wolfgang Amadeus Mozart, but you can find the music notes from Mozart and realize that he existed, okay? And in the same way, we can find physical objects launched into space. I call that interstellar archaeology, because they keep accumulating over time in the Milky Way. Unlike radio signals that if they were emitted 1 billion years ago, they are now 1 billion light years away, so we can't really chase them. But probes or spacecraft that were launched 1 billion years ago, if they were launched at tens of kilometers per second, the way we launch our spacecraft, they are gravitationally bound to the Milky Way. So they keep accumulating in it. So the Milky Way gravity is sort of like a wastebasket. It collects everything. And you can imagine some space trash, like the New Horizons spacecraft will be in 1 billion years. It will not be operational. So there could be objects that are just trash, that are not working, but they're still artificial. Or you can imagine functional objects, objects that are still working, like maybe the government unidentified objects.
Thank you, Professor Mauro. I wanted to ask you, because when Avi Loeb looks at the sky through the telescope in a certain way, also is traveling back in time and looking into the past, you do the same in a very different way. Of course, you move in the discipline that is very different from his. However, I wanted to ask you, you also addressed the subject of ET life in your work. Can you tell us something more about that?
Sì, certo. Il mio lavoro è ovviamente quello di analizzare e leggere i testi antichi. E devo dire che nei testi antichi è un po' come scrive giustamente anche il professore, guardare lontano significa guardare indietro nel tempo.
He's explained that his job is in some way in analogy with astronomy, which allows you to look really far back into the past. He's saying that looking at the historical old books like the Bible itself is a way to look into the past as well.
Poi sappiamo bene che la storia, a differenza della scienza, opera secondo categorie diverse.
And history, unlike science, operates with a completely different set of categories.
Noi non abbiamo, ad esempio, la possibilità di avere la prova certa di come è stato ucciso Giulio Cesare e non possiamo ripetere l'evento, che sono queste le caratteristiche richieste dalla scienza.
Sure, historians cannot fulfill entirely the scientific method because they don't have a chance to have an empirical proof of how Julius Caesar was killed, and they cannot replicate the experiment.
Noi quindi, occupandoci della storia, dobbiamo per forza di cose dare fiducia alle testimonianze.
So the main difference here is trust, because an historian has to trust its sources.
E questo è ovviamente da un lato un limite, dall'altro è molto affascinante perché leggere i testi antichi ci consente di affrontare dei contenuti che sono alle volte straordinari.
So this is a limit on one hand, but on the other hand adds an extra charm to this endeavor because we are reading human-made documents. So sometimes the results are extraordinary.
And so, for example, talking about the aerial object Oumuamua, you, professor, wrote that I submit that the simplest explanation for these peculiarities of the object, obviously, is that the object was created by an intelligent civilization, not of this earth. And in another page, you made a question. Throughout the expanse of space and over the lifetime of the universe, are there no, or have there ever been other sentient civilizations that, like ours, explored the stars and left evidence of their effort? So I have this question. Do you think theoretically, of course, that is possible that the ancient writings have memories of contacts that took place in the past? I say theoretically, of course, because we have no evidence. We have only oral, written, or iconography testimonies. But
right.
What do you think about that?
Right. So the Earth existed for 4.5 billion years. Okay. And then Homo sapiens came to the scene about 2 million years, a few million years ago. Okay. That's when we started. And before that, you know, most of the Earth history did not have humans in it. And of course, if any spacecraft came to visit Earth, it would appear as you know, a habitable planet that has a lot of microbes, bacteria, has definitely life in it, but you know, and there was a period of time when there were giant animals like dinosaurs, and they were killed by an asteroid impact. So obviously there was a history to life on Earth. And any spacecraft visiting the solar system, the habitable region, would conclude that Earth is habitable, that it has life, but not intelligent life. Okay, it was relatively primitive until the last few million years. Okay, so that's just very recently. It's a factor of 1,000. Okay, so just the last 0.1% in the history of the universe, that's where intelligence starts to come into play. And then even then, the history is not recorded. So only the last 10,000 years are recorded of human history. So that's another factor of 100. So we are talking altogether about 100,000 of the age of the Earth that has recorded history, human history. Okay, and that's tiny. But even within that, there are you know, there are reports of unusual phenomena. I mean, all the miracles that are reported in the Old Testament and things that are unusual. You know, there are things that were constructed like the pyramids. There are all kinds of things that appear to be quite exceptional, But we, as you said, we don't have a conclusive evidence because there was no photography at the time. There was no way to document things the way we are documenting now. So when Enrico Fermi says, "Where is everybody?" that was 70 years ago at lunch in Los Alamos. If you think about it, his span of data is much shorter than human history, which is a factor of 100 shorter than when Homo sapiens appeared, which is a factor of 1,000 shorter than the age of the Earth, okay? So it's really ridiculous of us to say, okay, at this moment in time, there is no neighbor sitting next to me on the sofa, therefore I don't have neighbors, okay? In order to find neighbors, you have to look around, and we will be lucky if there are objects that came from them that are hovering around the Earth, and that's the type of evidence the Galileo project is seeking. We haven't looked for that. I'm saying we haven't searched for objects near Earth in a scientific way that is well-funded, systematic, not relying on anecdotal military data, anecdotal reports from the public. We haven't done that. So for Enrico Fermi to ask this question is completely inappropriate. And for us to rely on past reports from before the scientific revolution that Galileo Galilei started, before that, it's not fully trustworthy if you look at texts and so forth. I mean, it's intriguing. It should encourage us to seek the data now. But so I completely agree with you that it's possible that someone else witnessed already what we will find as scientists, and that they just didn't have the means to document it in the right way. It's quite possible if this phenomenon is repeating and abundant enough for them to see it. But I'm also saying that if you look at the entire history of the Earth, the vast majority, 99.999% of it was not documented. And it's quite, if there was a visit, it's quite likely that it happened when humans were not recording it.
Giovanni, thank you, Professor. Giovanni, do you also have a question for Professor Loeb?
I had a few questions, but the professor has answered both of them already without me asking them. And I wanted to ask something about the famous Fermi paradox, but we've just discussed this. And also before you mentioned that astronomers do not collect the signal that would be important for you. So my question was, what about James Webb Telescope, this fantastic machine that is orbiting our planet now, that is providing such beautiful images? And I was wondering if you are waiting for, if there is any signal that would be of any interest for you, and if not, what else of our current apparatus that we have orbiting Earth or on Earth could give you some evidence of something already operational?
Well, that's an excellent question. I was actually on the first scientific advisory board that designed the Webb telescope back in 1995. Back then, we were mainly aiming to image the first stars, the scientific story of Genesis, let there be light, which the James Webb Space Telescope is already doing. And there was a celebration of the first deep image of the Webb telescope at the White House just a month ago. And so with respect to finding extraterrestrial intelligence, there are several ways that the Webb telescope can be helpful. First of all, if there is an object like Oumuamua that looks unusual, the Webb telescope is about 1.5 million kilometers away from Earth. And if we look at that object that comes within the orbit of the Earth around the sun from the Webb telescope and look at it also from Earth, then you would see the object from different directions. And that allows to pin down the trajectory of the object in 3 dimensions. It's called parallax in astronomy. And so that will give us a very good handle on any propulsion or non-gravitational forces acting on the object. Moreover, the Webb telescope can take a spectrum of the object in the infrared and infer something about the composition. So that's with respect to an object like Oumuamua. We didn't have a telescope with the same sensitivity and location as the Webb telescope when Oumuamua came along. We just had the Hubble Space Telescope, which is very close to Earth. So the other thing that one can look for with the Webb telescope is, for example, artificial lights on the night side of a habitable planet, nearby habitable planet. For example, the nearest star, Proxima Centauri, has 2 planets in the habitable zone. It's a dwarf star. And just imagine these planets being tidally locked, so they have a permanent night side and a permanent day side. If there is a civilization on those planets, they might decide to warm up the night side, which is cold, or illuminate it with artificial lights. And in principle, we can see city lights on the night side of those habitable planets around Proxima Centauri with the Webb telescope. I wrote a paper about that. Another thing that can be done is looking for industrial pollution in the atmospheres of planets. We usually talk about looking for oxygen, methane as indicators of primitive life. The thing is that oxygen did not exist in large abundance in the Earth's atmosphere for the first 2 billion years. So even though there was life, there wasn't much oxygen. So it's not necessarily an indicator of life, but if you find industrial pollution like those CFC molecules that nature doesn't produce because they're very complex, then, and I wrote a paper about it in 2015, then that would imply not only life, but intelligent or industrial life. I shouldn't say intelligent because they might be destroying their climate with that industrial pollution. So that's another way that the Webb telescope can help in this context.
Thank you very much.
So, Professor, we don't have much time left. We have to go. We have to start going towards the end. But I want to ask you to finish a couple of quick questions. The first one is if you can tell us more about how can we, or if anybody wants to contribute to the Galileo project. And the second one is this actually. Do you think that there is a possibility, a real possibility that there is some government makes public disclosure of ET life before you even find any data?
Yeah, so in terms of contributions to the project, there are 2 types. There is a scientific contribution, and for that, we have a form on the Galileo project website that anyone interested can fill up and express interest in joining the effort. The second type is financial support. And again, there is a form on the website if the donation is less than $50,000, if it's a small donation, but if it's above $50,000, then whoever wants to donate should approach me directly by email. And then with respect to your second question, I think it's the situation is similar to what is portrayed in the play Waiting for Godot by Samuel Beckett. You know, you can wait forever for the government to declassify data. I don't think they will do it. And the reason is that the data was assembled by classified sensors, and they don't want to reveal the sensitivity of those sensors, the characteristics, because they're used for national security purposes. So if they were to release some photographs, it would become clear what kind of satellites are collecting those photographs or what kinds of other sensors on the ground. So they will not release the data, not because of the data, but because of the instruments used to collect the data. Okay.
Do you,
and therefore, yeah.
Do you speak with politicians about these subjects? Do you have the chance to discuss this?
Well, yeah, every now and then I have a conversation. And in fact, I was attending an event in the Washington National Cathedral at the beginning of November 2021, together with Bill Nelson, Avril Haines, the Director of National Intelligence, and Jeff Bezos. And in the green room, before we went on stage, I was speaking with Avril Haines, the Director of National Intelligence, and I asked her, you know, what do you think these objects that you reported about, what do you think they are? What's your gut feeling? And she said, I don't know. Now, she was trained as a theoretical physicist at the University of Chicago. So she knows physics. And to me, it illustrates a situation where, you know, the government simply doesn't have the tools. It's not a scientific organization that can go and dig deeper. As long as it's not a national security threat, they just leave it aside, or at least they don't talk about it publicly. And that's where scientists should come to help in clarifying it, because the sky are not classified. And the other thing that I hear from my colleagues is that extraordinary claims require extraordinary evidence. But that was a statement made by Carl Sagan. But my point is extraordinary evidence requires extraordinary funding. You know, that we invested billions of dollars in the search for dark matter, most recently with the Large Hadron Collider. We didn't find the lightest supersymmetric particle with the Large Hadron Collider that cost $10 billion. That's not a problem, but it shows you that science very often is searching for the unknown and doesn't find it. My point is, if we invest billions of dollars in the search for equipment from other civilizations, and we do not find it in several decades from now, we would be exactly at the same point as dark matter searchers are right now. So saying extraordinary claims require extraordinary evidence and then not providing any funding towards the search is a circular argument. And nobody said that the lightest supersymmetric particle is an extraordinary claim, therefore it shouldn't be funded. People said, oh, that's interesting, let's check it. And they put billions of dollars. Now, why can't we apply the same approach to objects that came into the solar system that look weird and just examine them, because maybe one of them would be a spacecraft? Like, why is that so controversial when we are sending out spacecraft out of the solar system? I don't understand that. It really conflicts with my common sense.
This is very, very interesting, and we could go on speaking about this for hours, asking you questions, Professor, but unfortunately the time is a tyrant, so we have to start closing. And I would like to thank Giovanni Zattra for your contribution, for your questions, and
thank
also
you
good
for
luck
having
with your research. Mauro Biglino, thank you very much. Mauro's book, The Bible Doesn't Talk About God, on Amazon Italy, in the relevant section, is #1, which means that in Italy is selling more than the Bible itself. So you might want to take a look at it.
Is it true also in the Vatican or just in Italy?
Amazon Italy. I don't know if there is Amazon Vatican. Thank you very much, Mauro. And
thank you all.
Professor Avi Loeb, thank you very much. Good luck with your pioneeristic quest for ET Live. I'm going to include in the description of the video the links to make a contribution to Galileo Project, and also to your Italian translation of your book, We Are Not Alone, Non Siamo Soli. Thank you very much, Professor.
Thank you for having me.
Please push the buttons below that you prefer, like, share, and subscribe, and till next
That's not our LNS though, is it? It's not.